I'm Anil Kumar from Toronto, Canada. I'm glad we have two students here to learn advanced functions. We'll talk about parent functions and their characteristics today. So, would you like to introduce yourself first, Mr. Mohammed?
Hello, I'm Muhammad. I'm from Oakville. I'm a grade 11 student, and I'm taking this course to try to get prepared for the math concepts in the future. Yeah.
Ms. Vishruta, please.
Hi, my name is Vishrutha. I'm doing grade 11 right now, and I'm doing advanced functions because it's an important topic that's going to be beneficial in the future.
Sure. So, let me share with you the lesson which I prepared for you today. So, we'll now talk about parent functions and characteristics. Can you see the screen, please? Both of you, right? So, in functions, whenever we talk about these functions, we consider the parent function, which are the basic functions. And if you do transformation or change these functions, you can make all other functions. That is the whole or combination of these functions can give you all other functions. Therefore, the knowledge about the parent functions is very, very important. So that is what we are going to do today. We are going to learn and understand about all these parent functions. So let me begin with a few which are listed here. We'll talk about the characteristics. First thing first, I have given graph of few functions here. Can you recognize all these functions? Which is this particular function? Can you name it? It's a linear function, a straight line, correct? How about this one?
It's the, what do you call it?
Absolute value function, which we did last time, correct?
Oh, yeah.
This parabola is a graph for y equals to x square, a parabolic function, correct? Now, this is a cubic function, which is a polynomial like x square, but it is x cube, right? This is graph of which function? Reciprocal function, 1 over x, okay? Do you recognize this graph? Exponential function, 2 to the power of x is our base parent function. This graph is of square root of x, correct? And this one? Sine x. So these are the 8 functions which we will talk about and understand their characteristics, okay? So let's begin with lines first. Now, as last time I discussed, whenever we will talk about functions, there are a few characteristics which we should go about, right? So this table gives you all the characteristics which we should be writing down for each and every function. Once we do that, then we have really understood the function, and our understanding will be to the level of advanced functions, right? So here we are listing the characteristics of the function. First thing first, we should know the key points to sketch the function. Whenever I say key points, we're looking into at least 5 points to sketch the graph. For a straight line, -2, -2, -1, -1, 0, 0, 1, 1, 2, 2 are good 5 points to check. Then we talk about domain and range. Domain means what inputs can the function take, and range is what is the output which the function gives. Correct? For a line, a straight line, as you can see, any input, any real number can be the input. Therefore, the domain is all real numbers and the range is also all real numbers, as you can clearly see from the graph. Is that clear to you? Then we talk about symmetry. Now, this function is symmetric about a point, and with that point is the origin itself. When we say symmetric about a point, which is origin, really it means that if I have a point on a line, it will be also having a reflected image on the function. Do you see this? So there is a corresponding point on the other side as if a mirror is put at the origin, right? So this is called odd symmetry. Odd symmetry is symmetric about the origin. Then x and y intercepts. It intercepts x-axis and y-axis at the origin, and therefore x and y intercepts are at 0, 0. Now these are kind of important characteristics: decreasing interval and increasing interval. Whenever you look at a graph, we have to see from left to right. Okay, so whenever you're looking at a graph, you have to always see from left to right. Now, if you see from left to right, what happens to the function's graph? It is always increasing, correct? It is never decreasing. And therefore, we have written that decreasing interval, it never decreases. So that is, we sometimes write in function notation as a null set, never, right? So the phi designates a null set, means never. Okay. Sometimes we also write it in open brackets like this, means there's nothing inside. It is never decreasing. Increasing interval, throughout its domain, x belongs to real numbers, it is always increasing. Correct? End behavior. Now, end behavior is a very important characteristics. We want to see what happens to the graph of the function when we are going to a very high, very large x value, negative x value, very large, or a positive next x value, very large. Then what happens to the graph of the function? As you can see, if x value is very large negative, the function goes very large negative value, approaches negative infinity, correct? For a large positive value, the function approaches positive infinity. Perfect. So that is written like this. X approaching negative infinity, that's arrow, gives me x is approaching. You can never be there at infinity, right? So x is approaching negative infinity, y approaches negative infinity. Do you understand the nomenclature in which we have written? Vishruta, is this clear to you? The way I've written? When x, we say x approaches negative infinity, y approaches negative infinity. Do you see this is going downwards towards negative infinity? Negatively large value. That is how we are going to write. Also, when x approaches positive infinity, in that case, y approaches positive infinity. Correct? Do you see this portion? If x value is very large, y value is also very large. Correct? Now, rate of change is you have learned in line slope, right? So if you take 2 points and then find rise over run, on a line, rise over run is always constant, correct? Therefore, we can say that the rate of change is constant, and for y equals to x, which is our function, it is 1, right? M value is 1. Now, as you can see, the graph, this is quadrant number 3, right? And that is quadrant number 1. So we see that the graph actually goes from quadrant 3 to 1. And that is what I've written here, that quadrants, it is in 3 and it goes to 1 through origin. Discontinuous. This is a continuous function. Some functions which we'll talk about will be discontinuous. The reciprocal function is discontinuous, correct? Now, when we talk about a straight line, there are two important lines. One is the horizontal line and one is the vertical line. Can you tell me which one of these is not a function? Is vertical line a function? Okay, function means that for every input, we have only one output. That is a function. For example, let us say we have a relation like this, and we are saying square of a number. Then if the input is 1, then square of it 1 is 1, correct? So it is a relation in which every input has only one output.
Okay.
If I have 2, then 2 square is 4. So that is how a function is defined. But there,
So
yeah,
so then it is a function, right?
yeah, it is a function. But vertical line, what happens to a vertical line? On a coordinate plane, if you draw a vertical line, which is kind of like this, in that case, for one value of x, it has so many values of y, right? So it is not a function. You get the idea? Because see, what is this coordinate point? Let us say this point is 2. And this point is, let us say 1, 2, 3, 4, 5, right? All these points have all x values same, right? And those x values are related with different y values. That means one x value has many y values, and therefore this is not a function, but it is a relation. Is that clear? On the other hand, if I have a horizontal line, now here for one x value, how many y values I have? Only one, right? For another x value, again, same y value, but x value is associated with only one y value. You get the point? So it is again a function. So if I have a line, let's say y equals to -2, in that case, the domain will be all real numbers because x can be any value. However, the y value will be only -2. You get the idea? This will be mapped like this. For each and every value of x, we have only one value of y. Do you see that? So many are related to 1. Many x values are related to 1. So this will still be a function because none is related to many. Is that clear to you? So that will be a function. So a function will be when there is a relation which is 1 to 1 or many to 1. And what is not a function? This is a function, right? And what is not a function? Let me write down not function. When we have 1 to many. That is not a function. For example, mother has many children. It is not a function. Okay? Mother says, my son is good in badminton, for example. We don't know which son mother is talking about if she has more than one son, right? That is what defines everything is a relation. So all these things are relation, but relations in which every input has exactly one output will be called as a function. Is that clear? Right. Second thing which I should also say at this stage is notation, function notation, right? Let me just say. All the time we had been saying y equals to 2x plus 3, right? We say y equals to x plus 4. We say y equals to minus x minus 2. Let us say. So every time till now, we had been using x and y where y is related with x, right? Y is a function in all these cases. All of them are lines. However, if we change y with, let's say, f of x, since it is a function of x, we give it a name. So this is called function notation. Clear? Giving a name to the function is function notation in a way, right? Similarly, we could give this name as a g of x. We could call this as h of x. That becomes a function notation. So I think this is important for you to understand since you have not done functions earlier, correct? So Ankita, how are you doing?
I'm doing good, sir. How are you?
Very good. We just started, so it's okay. You haven't really missed much. We are
Yeah,
talking.
sorry about that. My internet's been really weird these days.
Okay, no problems, no problems. Good you joined. So, Ankita, we're talking about linear function at present. So I'm just telling Mohammed and Vishruta about function notation. So naming a function is function notation. Instead of y, we have written f of x for this function. Instead of y equals to x plus 4, we have written g of x, right? Do you see that? Now I'll show you advantage of function notation. This is very important. If I write f of 1, it means what? It means this particular function I am talking about. And I'll substitute x as 1 here because x has been named as 1. For 1, what is the value of this function? So we'll say 2 times 1 plus 3, which is 2 plus 3, which is 5. Do you see that? How we use the function notation? If I say g of minus 1, it means what? Substitute x as minus 1 in the function g of x. So that will be, x will be substituted by minus 1. So we'll write this as minus 1 plus 4, which will give us 3. Do you see that? I could say h of, let us say, 3. That means in this equation, I'll substitute x with 3. So I get minus 3 minus 2, which is minus 5. Do you see that? That is how we could work with equations, because now we have given it a name. I could also do something like this: f of 2 divided by g of 2 times h of 3. Do you see that? That becomes an equation. And I'm not talking about all these equations using them in a different way. So that is a huge advantage of function notation. By naming them, we can do so many operations. Mohammed, is this point clear to you? Naming makes that much of difference. Okay, so we'll talk about function notation most of the time. We'll not just say y, we will say f of x or g of x. We'll give it a name. It becomes simpler. Okay, and that is how we are going to use. Okay, so Ankita, we are talking about the characteristics of the function. The very first function is the linear function, as you have seen, and these are the characteristics which I think you're aware of, right? You're aware of the characteristics of linear function?
Yes, I am.
Yes. So now here's a screen for absolute function. We did these characteristics earlier, correct? But again, I filled in all the values as we filled in our last class, correct? So you see, this becomes very important. The only thing which I've added here is that the absolute function goes from quadrant 2 to quadrant 1, correct? And another important thing here is to consider the rate of change. If you compare with the line has a rate of change constant of 1 on always, right? So here the rate of change is 1. But on this side, the slope is negative. Do you see that? So here the rate of change is minus 1. So that becomes a difference between the absolute function and the linear function, the line. Is that clear to you? A major difference between the two. And of course, there are many other differences. One being that this is always positive, correct? That one goes from quadrant 3 to quadrant 1. This goes from quadrant 2 to quadrant 1. It is always non-negative, correct? Rest characteristics, you understand. One more important characteristic, which is the difference between line and absolute function, is symmetry. This function has even symmetry. Even symmetry means symmetric about y-axis, and the line had odd symmetry, correct? So this one is clear. I'll move on to parabola, which is this particular function. Now, parabola is normally given by the equation f of x equals to x squared. You know a lot about parabola. I would like you to answer this question. What is the decreasing interval of parabola? Can you tell me, please? When is it decreasing? Yes, Vishruta? Yeah, Mohammed, tell me.
Or we're going from left to right, right?
Yeah.
It's decreasing from negative infinity to 0.
You're right. So it is decreasing. I could have written like this. Let me write, not including negative infinity and up to 0. Correct. And it is increasing thereafter. So we can write like this. Is that clear to you? Definitely. We could also write x is less than 0 or x is greater than 0. As you have seen here, there are so many ways to write these intervals, correct? All are correct. These all them are correct. Now, can you tell me about the rate of change? Is the rate of change increasing or decreasing over the period of time? Or it is changing from decreasing to increasing? What is the correct answer? This is a very critical question. Rate of change over the graph of parabola. Is it always increasing, always decreasing, changing from decreasing to increasing? Which is the correct option? Tell me.
It starts, wait, we're going from left to right, right?
Yeah.
So it starts decreasing, and then when it gets to 0, 0,
Hmm.
it starts to increase.
Okay. Rate of change is kind of a tangent slope. So if I draw tangent at these points, what happens to the tangents? Ankita, can you explain me? Rate of change for the graph of parabola. Is it always increasing, always decreasing, changing from decreasing to increasing? What is it?
Um, I feel like I want to say that it's going from like decreasing to increasing, but I feel like this is a trick question. So
Okay, what is the slope of a line on this side? It is negative, right? Slope, tangent, coming down.
yes,
What is the slope at this point? 0, right?
0,
What is the slope on this side? Positive. Do you see that? So slope, if I go here, it is less negative. Here it is more negative. Do you see it's steeper? It is steeper here, right? Less steep. So let us say we give it a value. Let's say -5, -2, right? -1, 0, then becomes 1, 2, 3. What is happening to the slope? Tell me.
Increasing.
Always increasing. Do you see that part? It is always increasing. And do you see, if you measure the slope, rise over run at any particular point when you draw a tangent, you notice that it has become less and less negative. It becomes 0 here and then more and more positive. So basically, the slope is always increasing. Do you get the idea now? Is this point clear, Vishruta? Very common question, which will most students will get it wrong. Multiple choice. Okay. So that is a very, very critical thing to understand when we talk about parabola. Now, let's talk about other polynomials. Now, polynomials are all these curves in general. We write a n x to the power of n. This is our parent polynomial. N could be any integer. N belongs to positive integers, okay, non-negative integers, positive integers. So, for example, if I have x to the power of 4, x to the power of 5, x to the power of 10, all these will give some kind of a graph which will look very similar to either a parabola or to this. Okay, and therefore, in the last example, I have also mentioned here that any function x to the power of 2n, do you see that 2n? Even powers. So if I have the graph of x to the power of, let us say, 8, the graph will be kind of like this. It will be, I'm showing it like broader. If I have a graph of, let's say, x to the power of 4, it will be kind of not that broad. Do you understand? I'm just trying to show here that this broadness will be more if the power is higher. Is that clear to you? But they will be similar. So any even power polynomial, highest degree, will have this kind of a characteristics, which is for a parabola. Is that clear to you? Similarly, any odd power will have this kind of a characteristic. Only thing will be that the graph could be like this, more steeper. I mean, this. Do you understand? Higher degree will be more steeper. So if I have x to the power of 7, it will be flatter here. Do you see? More flat. And then again more steeper. Correct? Where will all of them intersect? At 1, 1, they will have a common point. Correct? Because 1 to the power of n is 1. Correct? And minus 1 to the power of n is also minus 1 when n is odd. Right? N is odd. Let us write 2n plus 1. Then it becomes odd. Correct? So that point will be common. So basically what I'm trying to say here is something like this. We have one graph. Oh. All the graphs will go through these points, which are 1, 1, minus 1, minus 1. Is that clear? The only difference will be that if I have a graph like this will be more steeper. If this is, let's say, x to the power of 5, this is x to the power of 9. You get the idea? So, but they will have these common points because 0 to the power of anything is 0, correct? So they have a similar characteristic and behavior is same, x-intercept, y-intercept, all those behaviors, domain range, everything is same, whichever we are defining here. Is that clear to you? Increasing interval, decreasing interval, all are same, correct? Perfect. Now, this graph, is it ever decreasing? It is always increasing. When you see from left to right, it is always increasing. And therefore, the decreasing interval never and increasing interval always. Now this you could always write as x belongs to real numbers. You could also write this as from minus infinity to plus infinity. Let me write it short form, minus infinity. So these are different ways of writing the interval. Is that clear? Interval written in brackets. And behavior. If x approaches negative infinity, that is a very large negative value, then the power will be even larger negative value, correct? For odd degree. So y also approaches negative value, as you can see here. And if x is very large positive value, then y is very large positive value. So that becomes the end behavior. So have a good look at the screen. It gives you characteristics of a cubic function. Clear? Or an odd degree polynomial. You can always say these are characteristics of odd degree polynomial. Now, polynomials is our next chapter. We'll look into this in more details in the next chapter. Okay. So odd degree I've written as 2 to the power of n plus 1. X to the power of 2n plus 1. Perfect. Okay. And all these graphs go from quadrant 3 to quadrant 1, like a straight line. Straight line is also a polynomial. Okay, reciprocal function. Reciprocal function is 1 over x. And the graph is kind of like this, as shown here. The key points are mentioned. So reciprocal of 2 is 1 over 2, minus 2 is minus 1 over 2, right? Reciprocal of 1 is 1, reciprocal of minus 1 is 1. And as far as 0 is concerned, it should not have been there. That is not in the domain, correct? That is a typing error. So at 0, you cannot have 1 over 0. 1 over 0 is not defined, correct? Therefore, in the domain of the function, domain is all real numbers where x is not equal to 0, and range is all real numbers where y is not equal to 0, correct? Now, there are two very important characteristics, and let's talk about those, which is horizontal asymptote and the vertical asymptote. What does that mean? Horizontal asymptote means that if the value of x is very large, then is the y value approaching a limited value? So as you can see, if I divide by a very large number, then what is the result? It is 0, correct? Approaching 0. If I say 1 over 100, it is a very small number. 1 over 1000, even smaller. 1 over 10,000, much, much closer to 0. Do you see that? It is positive though, and therefore we see that it approaches 0 from the positive side. And therefore, in the behavior, we are saying when x approaches positive infinity, y approaches 0 from the positive side. Is that clear? But on the other hand, if I talk about x approaching negative infinity, if I divide by a negative number, I am going to get a negative number, correct? If that negative number is very high, I am going to get some number which is negative but close to 0, correct? So that becomes the end behavior, and we say because we are approaching 0, which is a valid value, we have a horizontal asymptote y equals to 0. You get the idea? We have a horizontal asymptote y equals to 0. So that is a technical term which is defined here. Is that clear to you? So horizontal asymptote, we will say, is a value which the function approaches when x value is very large. It could be negative or positive infinity, approaching infinity. Is that clear? Now, second part here is about the vertical asymptote. Sometimes what happens is when you approach a point, the y value all of a sudden becomes like a very, very high value. It could be very high positive or very high negative. That is the place where we have a vertical asymptote. So when we are approaching 0, 1 over 0 is not defined. It's a very large value. But when you approach from the positive side, you get a positive answer. For example, 1 divided by 0.00001 will be very large value but positive. So we are saying approaching positive infinity. But 1 divided by negative 0.00001 will be large negative value. So we are approaching negative infinity. So that becomes a vertical asymptote at x equals to 0. Because when you are approaching x equals to 0, you get a very high y value. So it becomes a vertical asymptote. And it is shown by a vertical line, dotted vertical line in any graph. Means it is approaching, but it is never there. So this graph will not have x-intercept, nor will it have any y-intercepts, correct? It is approaching, but it is never crossing that particular line or, right, touching it, right? So in this particular case, we can see that it does not have x and y intercepts. X intercepts are also called zeros. We'll talk about zeros and difference between x intercept also. Okay, we'll take that up. Now, second, rate of change. Now, why am I taking rate of change? Because rate of change is least understood by most of the students at this stage. Can you tell me, for this particular function which you're seeing, is the rate of change always decreasing, always increasing, or sometimes decreasing, sometimes increasing? Yes, tell me. Mohammed, give me a guess. What do you think? Rate of change.
It's always decreasing from left to right.
Okay, how do you say always decreasing from left to right? Here it is 0, here it is negative, correct? So when it changes from 0 to negative, it is decreasing, correct?
Yeah.
Perfect. How about this place? Here it is negative and become?
Positive? What?
It is 0. So from a large negative value, it becomes 0. So it is
Decreasing? Oh no, it's increasing.
correct? In this case, it is going from 0 to negative, right? And more negative. Do you see that? So it is decreasing, correct? So rate of change. So rate of change is, it is decreasing from minus infinity to 0. Because becoming 0 to negative, decreasing from minus infinity to 0. Do you see that? But it is increasing from 0 to infinity. Do you see that? Is this point clear? Vishruta, did you understand this point?
Yeah.
When it goes from 0 to negative, means it is becoming lesser and lesser. This is infinitely large at this point, correct? Vertical tangent means infinitely large, correct? Because you are approaching from this side, very, very large negative value. So definitely it is decreasing. On the other hand, from infinitely large to 0 means increasing. You get the idea. Now, as far as decreasing interval and increasing interval is concerned, you can see that the function is decreasing. The value is decreasing, correct? And here also the value is decreasing, correct? So this part is correct, that the function is always decreasing in its domain, not at 0, because it is not defined at 0. Is that clear to you? So decreasing interval and rate of change is sometimes very confusing. So you have to look at it very carefully. There's another term which I have not added in this table, which I think we should add, is when is the function positive and when is the function negative. So in quadrant 1, it is positive, right? So it is positive in this case when x is between 0 to infinite, greater than 0, right? And it's negative when x is less than 0. Is that clear to you? It is negative here and positive there, correct? So you can add this to your characteristic list. When is the function positive and when is the function negative? Okay. Now let's talk about exponential functions. Exponential functions, the graph is shown to you. As you can see here, these are always increasing, correct? Now, can you tell me about rate of change? Is the rate of change, what is happening to rate of change? Yes.
Increasing?
Increasing, because it is 0 here, right? So just say, check the tangent, 0 and positive. Do you see that? So that means it is increasing and more positive. Perfect. This function is always positive, always increasing, continuous domain. These are the characteristics of exponential functions, correct? And then you can fill up all these columns. You can also add a column here, which is say when is the function positive and when is it negative, right? So it is never negative, correct? You can add two more columns. Is that clear? Rest characteristics are clear. I would like you to, there is a question always writing, make a table, just as we have done, for all the parent functions and write these characteristics down. That will help you. Now, a square root function is another function, and you see square root is always in only quadrant 1. That means it is the most restricted function. Domain is only x greater than 0. It is only in greater than equal to 0, right? So it is the most restricted. Do you see other functions were in quadrant 2 or 3 also, right? And the range is y greater than equal to 0. Very clear. And this function is always decreasing or increasing? Tell me.
Always increasing.
Always increasing. What about the rate of change?
The constant?
No, this is the line which is, see, the rate of
Oh
change.
no, never mind. Oh, yeah, never mind.
Tangent. What is happening to the rate of change? Yes, tell me. Is it always increasing, always decreasing? What is happening?
I mean, it looks like it's always increasing.
No.
Is it always?
This is a vertical line means kind of infinitely large, right? It is positive and this is less positive. Do you see that? The slope is like this. Do you see that? Less, less, less. Do you see?
So it's gonna increase. And it's gonna slowly stagnate, like to straight line.
Yeah, it is always decreasing as you move from left to right. Always decreasing as you move from left to right. Do you see that? Initially, it is very, very high, undefined, in fact. Vertical line is the slope at 0. And then it becomes, it is still positive, high positive, low positive. Do you understand? The value is decreasing. Let's say this value is 10, then we have a slope which is 8, then it becomes 6 like this. Is that clear to you? Slope of the tangent line. Is that clear? If I draw a tangent here, it will be kind of like this, right? At this place, the tangent will be like this, less slope. Clear? So as you can very clearly see, that rate of change is very important to understand. And let me tell you now one more thing. When you look into your book, rate of change, they are not even talking about in this chapter of characteristics of functions. Ankita, you are getting it?
Yes, I'm getting it.
Rate of change is the next chapter, is I should say next unit. But in unit 1, they have not discussed this even in the characteristics. And that is why it becomes even more difficult for students to get. But I think now you got an idea of what is rate of change and what we understand by increasing function or a decreasing function. Both are different things. The function is increasing, but the rate of change is decreasing. This is a very unique example. If I ask you which is the function which is always increasing, but whose rate of change is always decreasing, tell me. Square root function. Make it a note. Write down. Which is the parent function which is always increasing, but whose rate of change is always decreasing? The only function is square root function. Is that clear? Perfect. So we have come to know about these functions. Now here, we'll talk about the sine graph. Trigonometric function. Have you all dealt with trigonometric functions earlier? No? Okay. It's a sine curve as you can see, right? So it can have any x value. So we say domain is all real numbers. Domain is all real numbers, correct? As far as the range is concerned, the maximum value is 1 and the minimum is -1 for any sine function. Sine is basically a ratio of two sides of a triangle, basically. Let's say this is the angle theta. This is the 90 degrees, right? So sine theta is what? Sine theta is opposite over hypotenuse. Correct? Now, hypotenuse is the longest side. So this cannot be more than 1. Correct? This is the opposite side. Therefore, sine theta has to be less than 1. At the most, it will be 1 if my theta equals to 90 degrees. If I keep on increasing, then it may become 1. Is it okay? In a circle, that is how the circle is. So if I have a circle, in that case, you will notice that sine theta, if I have a unit circle, let us say this hypotenuse is 1, right? So if I make hypotenuse equals to 1, then it becomes opposite side, correct? If I say hypotenuse is equal to 1, that means unit circle. Is that clear to you? Unit circle means radius is 1. That means hypotenuse is 1. If I make a triangle here, correct? So in that case, what is the sine theta? Sine theta is a y value. So at this point, y value will be 1, correct? So sine theta for 90 degrees will be 1. So that is the maximum value it can have. As you move, it becomes lesser and lesser, but this will be minus 1 because it is negative, correct? So sine theta value is between negative value to positive value. Is that clear to you? Correct? So the range is restricted from minus 1 to plus 1. It goes through the origin. This is very important. X and y intercepts both are at origin. And this is something which we'll understand later. I'll get back to this. End behavior. At the end, we don't know what it is, right? When x approaches large value, it is oscillating. It is kind of like this. We don't know whether it be 0, 1. It gives any value between 1 and 0. And therefore, in this case, end behavior is not defined. It is oscillating and it is between plus and minus 1. Is that clear? Now, sine functions are periodic functions. They repeat, correct? It's like a heartbeat, which keeps on repeating the same thing. So they are periodic function, and the maximum value, which is from this is called the axis. Axis is at y equals to 0 for this sine function. This is called the axis. And amplitude is how far away you are from the axis. That is the amplitude. So these are new additional terms for you for a sine wave to understand. Is that clear? Now, periodicity is one period, one cycle is this, which is 360 degrees, one full circle. So after one full circle, if I start a point here, and I'm saying that y value of this point is sine value, then after one full circle, it comes back to the same point, correct? So we say period is 360 degrees. Okay? Is that clear? Ankita, is that clear?
Yes, sir.
Okay. Now, what is the interval for increasing? It increases from here to there. Do you see this? Now, this value is minus 90. And that value is plus 90. So it increases from minus 90 to plus 90. Again, it repeats. After one cycle of 360, again it repeats, correct? This is a periodic function. And therefore, we could add 360 to this. So we can say, well, the increasing interval is from minus 90. Let me now write down here. From minus 90 to plus 90. That is my increasing interval, increases. But I could add to minus 90, 360 for the next cycle, right? 90 plus 360. Is that clear? That will also be increasing interval. This is also increasing interval, correct? After 360, you could add two values since it is a repeating function, correct? I could also say any integer multiple. I can add more cycles, correct? You get the point. Let's say you are riding a bike and you got a nail here in the bike. When is this nail going up? After every rotation, it goes up, right? Along this cycle. After every rotation, it goes up, correct? So that is 360k. One full rotation, it goes up. Two rotations, k is 2. After 3 rotations, it goes up again. You get the idea. So we can add 360k to it. Is that clear to you? Now, From these two equations, can I take 90 common? 90 and 360? I can take, right? So I take 90 common. So I get what? Minus 1 plus 4 times k. 2, I can take 90 also common here. 1 plus 4 times k, because 360 divided by 90 is 4. Is that clear? Now, I will rewrite this because I don't want to write minus first, right? So I'll write this as 90 times 4k minus 1 to 90 times 4k plus 1. Is that clear? And so I get my increasing interval, which is this. Do you match this value? 90 times 4k minus 1 to 90 times 4k plus 1 for any value of k, positive integers. Is that okay? It could be negative also. It works both ways. Correct? So, similarly, you can find the decreasing interval. Decreasing interval is from 90 to 270. So, if you do the same thing which I did, you will get that as your answer. Now, this is a very important question. You should understand how we got this result. It's like periodic function, right? So it might take some time, but practice after the class and understand how do we get this answer. Is that clear to you?
Yes.
Right. So very good. So we just talked about all these functions. Now let me take more questions based on our learning. Why is this very important? Functions. In our daily life, there are hundreds and thousands of examples, and we can always model them using mathematics, correct? Mohammed, can you read the first one and answer? How do we, the whole idea here is to understand how do we relate real life situations to functions, right? The first one, Mohammed, can you read this statement?
Height of a person above the ground in a Ferris wheel.
So out of the functions which we learned, 8 of them, which function do you think can model this particular situation?
I think it's going to be the sine one, right?
Perfect. Because as you can see, we are going in a circle, the height is going up and down, up and down. It is repeating, right? Maximum and minimum is fixed. If you start 1 feet above the ground and you go, let's say 20 feet, your height is between 1 and 20 feet. And it is periodically repeating as the revolutions per minute of the wheel. So it can be modeled using the sinusoidal function. You get the idea? So that is what it is. Now, second one, Vishruta, can you please read the second one and answer? Which function will help you?
Number of bacteria in a sample.
Yeah.
I think this would be exponential function.
Yeah, because they rapidly increase. Initially, cell division, right? So 2, 4 multiplied by 2 every second, for example, right? So exponentially increase. So any example we could model with exponential function, right? Ankita, next one for you. Can you read and answer?
So number 3, distance traveled by a car at a constant speed. Since it's using constant, I'm pretty sure it's a linear function.
That is right. So next one for you, Mohammed.
I think it's the parabola. What do you call
Correct.
it?
So quadratic function, polynomial, quadratic function. That's correct. Vishruta, next one for you.
Number of marks away from class average. I
Yes.
think it's going to be a linear function.
No. So average is fixed. How far away you are there from average, right? Either side, plus or minus that average. It's kind of a tolerance, right? Do you understand? Yes, Ankita, can you tell me number of marks away from class average?
I think it's also the parabola, maybe.
No.
No.
Mohammed, can you try? It is one of the 8 which we have not considered yet.
Is it the? I don't know the name of it. Is that one?
Yes, absolute value function. So, how much away are you from the mean? Do you understand? You again get it.
Oh,
Absolute value function is so tricky, you don't even know where to apply it. Forget about answering the question. You get the idea. It is that difficult. And I'm serious about it. So number of marks away from the class, if I have to model that situation, absolute value will work for me in most of the cases. Next one, please. Mohammed, can you tell me? Time of a pendulum oscillating as a function of length. We know this, right? 2 pi square root L over G, right? So that is, you learned physics. This is the time period of a pendulum, right? If you have a pendulum and it's like oscillating. So a square root function models this particular situation. And the last one, time taken to cover a fixed distance with different speed. Yes, Vishruta, can you tell me? Last one. If the distance is fixed and your speed is higher, it takes less time, correct? Low speed, more time. So what function will help you answer this question?
Is
Yeah.
it
Reciprocal function, right? Because the speed is higher, less time. So it is a reciprocal function, inverse, right? Reciprocal, correct? If you have to run 100 meters and if you run fast, you will do it in less time, correct? So time taken is lesser. And that is how you see so many applications can be covered with these functions. So that is one part which we need to understand. That is why advanced function is so important. And it is the basically foundation for higher mathematics. Because you have to first learn when you want to model what to use, which function to use, and then how to use. That is the second step. Okay, now we'll now talk about differences and similarities of the functions which we just learned. Now, some functions are very similar, but it's very difficult to find the differences between them. Some functions are so different that it's very difficult to find similarities between them. And therefore, in the test, they will always ask this type of a question. So, first one, try. Mohammed, there are two functions given to you. F of x is x, g of x is sine x. So, sine x and a linear function, how are they similar? Tell me. How are they similar?
Uh, they both have a y-intercept.
At origin. That is correct. Any other similarity, any one of you? Yes. It is to deal with symmetry. What symmetry both these functions have? Sin x and line, linear function.
Uh, the is it the one where is it even symmetry?
No, odd symmetry.
Oh.
It is symmetric about the origin. You see that? So both are symmetric about origin, and that is the other similarity. And therefore, this is a very difficult question because there are very few, similarities between the two. Correct? You get the point? So that is a sine function, and both are symmetric about the origin. Is it clear? Okay, differences, there are many. We can consider that the range is different. One range is fixed, the other one, we can say end behavior. The end behavior of sine function, because it oscillates, it is not known. But we know that for the other one, right? Increasing, decreasing interval, right? So there are many differences which we can list. Now the second one is reciprocal function and 1 over x. In these two functions, what do you think are the similarities and differences? Yes, Ankita, can you make an attempt?
Sure. Would it be the rate of change?
Okay, rate of change. Yes, you could say, but we are not looking for similarities. Tell me the similarities.
So you said we're not looking for similarities.
Oh, sorry. We are looking for similarity. What are the similarities between these two functions? There are many differences, right?
Okay.
Yeah. Domain, range, everything is different. But what are similar things between the reciprocal and the square root function? So that becomes an exercise for all of you. Think about it. So now you understand how difficult it is. So if you get to this situation where you really cannot find any similarity, I'll not tell you few. For example, if I have a point here, which is 1, 1, right? Is it common to both of them? I think it is common, correct? That is one similarity. So if you don't get any similarity, you have to write these kinds of similarities. Is that clear, Ankita?
Okay.
Right? And you can also say in quadrant 1, both are positive. Do you see that? Non-negative. Correct? Both the functions are non-negative in quadrant 1. Right? In quadrant 1, both are non-negative. One is also 0, but that is when we use the term non-negative, we say a similarity. You get the idea. Correct? So that is how we can actually say this. And of course, the rate of change is decreasing in quadrant 1, correct? In quadrant 1, rate of change is decreasing. Now, it is important to understand that we have to compare it in quadrant 1 only, since the domain of 1 over square root of x is quadrant 1. So we cannot compare it in other region. Is that clear to you? So rate of change for both the functions is, oh, sorry, not rate of change is a difference. Sorry. Rate of change is different. The 2 points which we have got is non-negative and 1 is common. Is that clear? Right?
Yes.
Now, look into these two functions, which is for you a parabola and absolute value of x. How are they different? Tell me. And how are they similar? So as far as similarities will go, what can you say? Mohammed, can you give me some similarities between these two functions?
They both have a point at the origin.
Yes, correct.
They're both, the rate of change for both is
Similar. Rate of change is different. So both go from quadrant 2 to quadrant 1. Do you see the similarity? You can say range. Range of these function is y is greater than or equal to 0. Is that correct? That is similar, right? Domain, x belongs to real numbers. It is similar, correct? So you can give many similarities like this. And of course, differences is, you can say, rate of change in differences, correct? The one rate is always increasing, right? Going from negative, and the other rate is kind of fixed and undefined at this particular point. So rate of change you can give in differences. Is that clear to you? So depending on the situation, and that is a must question, which will definitely come. Therefore, it is very important to understand this. Is that clear? Now, another important question in this particular exercise is that if I give you a characteristics, then you need to identify which function we are talking about. Is that okay? We'll do this exercise also. So which graph will have infinite zeros? Tell me, anyone.
Is it the reciprocal?
Sine function, because sine function repeats, right? So it is, do you see all the zeros?
Yeah. Sorry.
So which graph has no, rate of change of function is always increasing? Which is the function where rate of change is always increasing?
Is it exponential?
Oh, okay, both are correct answer. Continuous function where rate of change is always decreasing. Square root function, right?
Reciprocal?
Square root.
Oh, sorry. Yeah. Okay.
Even function with smooth curve.
Exponential?
It is not even. So even function is x square. You get the idea? Parabola. Y
Okay.
is equal to x square. Even function, right? Horizontal asymptote for a continuous function. Which function has a horizontal asymptote and it is continuous?
Absolute.
No.
Is it? It's
Horizontal
1 over x reciprocal?
No, it is discontinuous. 1 over x is discontinuous, correct? So which one is continuous and which has a horizontal asymptote?
Wait, how is a reciprocal discontinuous?
See, if
Does
you want to sketch it, it is discontinuous at 0, correct? Then you break it. It is discontinuous at 0. That is called discontinuous. Is that clear to you? It is
okay.
not continuous. There is a restriction in domain. In between, x is not equal to 0. So now tell me, horizontal asymptote for a continuous function.
Um,
Exponential?
Yeah, y equals to 0 is the horizontal asymptote. Is that clear to you? Origin is not in the domain of the function. Which is that function?
I think reciprocal.
Correct. Do you see that? So, such a simple chapter, it looks like very simple. When the teacher goes through it, you say, oh, we know all this, we have understood it. But when the questions are like this, the very first question is always objective type multiple choice. Correct? True or false? In that section, you will always find so many questions from this particular chapter. And they are actually very tricky. Okay. That's why I'm sharing these questions with you to give you an idea that this concept which we are going through looks simple, but it is not so simple. Hurriedly in the examination, you are bound to make mistakes and lose marks after marks. Correct? I don't want you to make these mistakes, and that is why we are going through all this. Is that clear to you, all of you, right? Do you appreciate?
Yes.
Now, a very difficult question for you. We will be starting polynomials next time, and therefore, this question is based on polynomial. Polynomial is any smooth graph like this, like, I mean, I kind of drawn like this. Do you understand? Those are polynomials. It could have combination of even and odd functions, many terms. So here is a question which says it's a polynomial function. It means a smooth curve. Do you understand? That is what a polynomial function is, kind of like this, right? Okay, and in which we have zeros at -2, 0, and 2. It really means that if I want to sketch, then when I say zeros at -2, 0, then we'll say 1, 0 is here. That means it is going to cross the graph at this point, which is x equals to -2. Then we have a 0 at 0, and then we have 0 at 2. These are the x-intercepts, okay? Now it says increasing in the interval from -2 to -1. So let me draw some guidelines. I'm just showing you a method of doing things. So I will call this as my rough work column, like this. So we are saying increasing interval in this region. So that means from -2 to -1, the function is increasing. Do you see that? And from 1 to infinity. So I have written here 1 to infinity. It is always increasing here. And we had zeros at 0 and 2. Is this portion clear? I'm showing you how, if we have a very complicated situation, how do we make a graph of that? This is very difficult. Therefore I'm telling you the tips, and with that you can actually do all the questions from your book, right? This is very difficult, not in the book, but book questions will be subset of this. Okay, now decreasing in the interval from minus infinity to -2. That means the function is decreasing all throughout. And then from -1 to 1. That means in this interval, it is the function is decreasing. That means the graph will come down. Negative interval 0 to 2. So from 0 to 2, it is negative, right? So negative from 0 to 2. Okay. Positive between uh, negative infinity to 0. It is positive here. And from 2 to, it is positive there also. So except for between 0 to 1, it is positive, and it is passing through a point which is 1 minus 9. So somewhere here it passes through this point. So that is the kind of function which we have to make. So if you do this rough work which I have shown you, do you see this rough work? So function coming down and a 0 here, and then it increases from here, correct? It increases from here and then goes up to this point and then turns back. Do you see it turns back and then increases, correct? Turns back and increases from here. So if I connect all these thoughts, how can I connect it? So I could say, well, we have to try it out. So let me use this highlighter. So up to 2, it is decreasing. So it is functions coming down. Do you see that? And at 2, it increases up to -1. So it increases. Do you see that? And then again it decreases and becomes negative here. So it decreases and it becomes negative. Negative when? Negative between 0 to 2. So after 0, which is also a 0, it becomes negative. It goes through a negative point, but when it is here, it after that point, it has to increase. And so after that point, it increases and goes like this. Do you see the graph which we have drawn from the description which we have at the bottom? What I'm trying to show you here is there could be many conditions given to you, more than 4, and then you will be told to draw a graph which match all the conditions. How will you do it? So in that case, in your space, draw your line as I have shown, and then do some rough work like I've shown here at the bottom. Once you do all your rough work, things will clear out and then you will be in a position to sketch the graph just as I have done. Is this clear to you? The method, right? Now, there is no fixed answer. You could have drawn any graph which could go through, but here we have a specific graph because we are also given a point to go through. So on a graph paper, when you're doing it, you could easily do it. Is that okay? Once you understand how do we go about. So this is the place where I'm going to end today's class. I think you have understood what these parent functions are, which are these 8 which we have discussed today. Okay. Now, I'd like to end the class, but I would like to know from you, what have you learned in today's class? Mohammed, can you begin? Can you start and tell me? What did you learn today? How useful was the class?
I learned about the reciprocal function, the sine function, and what's the one that goes like that? That function.
Absolute value?
No, it's the 4th one on the list.
Cubic function.
Yeah, that one.
Yeah, so these are all polynomials. So this function is called cubic, right? How about you, Vishruta?
I learned like details of all of the functions, but personally I learned more about exponential functions and reciprocal functions.
Very good. How about you, Ankita?
I think this was a little bit review for me because I already did take functions previously, and so it was just kind of a refresher
Yes.
about the different functions, and I know that this is going to help in advanced functions as well.
Yes.
And so I remember learning about like exponential functions in the function grade 11 functions course, so it just reminded me a lot about that, and sinusoidal as well.
Perfect. Perfect. So that is how it is. Yes, it is definitely a part of your grade 11. So it was a good review. And I think that will help Mohammed and Vishruta, both of you, since you did not take functions, right? And that was the reason why I went into so much details of this chapter today. Perfect. So that becomes a good foundation. Now you are like even with the grade 11 functions portions, correct? Next time, we'll actually start polynomials. Is that clear? So polynomials will be a new function for all these students. And I hope from there, everything will be, you'll be able to, get all the concepts and move forward. But now, I'd like you to open the book and do the questions from the book, this particular chapter, which is 1.3 for you. And if there is any difficulty, feel free to post those questions in our group and then we'll answer those. Is that okay? Fine. So we'll end the class today here. All the best. Thank you for joining. Bye.
Bye.
Bye, sir. Thank you.